All right. We had done sampling distribution, made a collection of samples for proportions yesterday. Now we're going to do the same thing and see what the properties are for sampling distribution with sample means. Okay, so yesterday our data was qualitative or categorical. It was the colors of the M&Ms. So in fact, we didn't even have a population distribution. We only could have the shape because we had p hats, all of our p hats, and I made a video of those results so you could see the class results as well. But let's move to days. So here is your data collection, and everybody can do this, even if you're at home. We want to just see how you do. All right, you're going to use the timer on your phone, and you are going to attempt to stop the timer or the stopwatch at exactly 5 seconds. So you're going to perform 30 trials because our sample sizes all have to be the same when we make a sampling distribution. And that is because it's kind of like common denominator type idea. We can't have willy-nilly all these different sizes of samples to make a distribution. They want to be same denominator, same size sample. All right. So put your 30. So once you do that, then go into your calculator and put your 30 times into your list 1 and find your one variable statistics. Now, based on, we've just come from a chapter or a unit that used list 1 with list 2's frequency. So we don't need that here. Make sure that when you go in to your calculator and you put your data on list 1, make sure you take off the L2 under frequency. You can just delete that or leave it blank or put the number 1. Either way. All right, and then find out what your sample mean and your sample standard deviation is from your calculator. See how well you did. So I did this, and let's take a look at what happened. Now let's keep some notation in mind. The population mean of all times. So that would be, say, all 300 amounts. So if I had 100 students, all 300 individual pieces of data. I have no idea what that shape's going to look like. And I am not going to put on a chart all 300 pieces of data. Okay. But if I did, then those would be centered at mu. That would be an average of mu. And it's probably going to be, it will be at 5. Okay. The population standard deviation is the standard deviation for all of those times. Now, technically, I don't have that because I cannot do that. So on the next page, I'm going to approximate that or tell you based on past results what the population standard deviation is. All right. When you get a sample, your personal sample will be an X bar. That is the average of the 30 times that you tried. So you get an X bar that we're going to put on the chart. And your sample standard deviation, see this notation, S of X. All right. So we need to keep those straight. Here we go. I did this the other day. I went ahead and even though I had done it in past years, I had lost that data. So I redid it. And I was pretty pleased with myself. Here's how I did. I put all of those in there. And I had a sample mean of 5.02. I guess when I rounded, when I put it on the chart, I'm going to put it on there as 5.02. My sample standard deviation is here. Now that's not going to play into our computing. We're really just going to need to know our X bar because that'll be a sticker that we're going to put on the chart. Okie dokie. So let's see how you did. All right. In theory, here is where things should be centered. I want you to notice this. This is saying that the mean of all of our samples should end up where the population mean is. Well, in this case, it should be 5 seconds. That's what this is, the population mean of 5 seconds, okay? Now, this is telling me how varied all of our little sample, all of our means should be. All of our little stickers that we put on the board, This is how varied our data should be. And do you notice you have to know the population standard deviation, and then you divide that by the square root of your sample size, and that's how varied all of our samples should be. Okay, which we're going to be dividing by the square root of 30. So look here. So in order, I have past results. And so past results suggest that we have a population mean of 5 seconds and a population standard deviation of 0.45 seconds. So let's see what our distribution should look like. Here we go. All right, so if the population is centered at 5 seconds, then the center of all of our X bars, all of our samples, should be at 5 seconds. And that's why I have that here on this chart right there at 5 seconds. Okay? And then here's how varied all of our samples should be. So the standard deviation of all of our X bars, of all of our sample means, should be that population mean divided by the square root of 30. So that's 0.08. So what I did was I decided to make a chart, and I'm making a chart to put on the board also to collect class data. And then I'll do another video tomorrow of the results that we get from the class data that happens tomorrow. But anyway, so do you see how here's the mean, and then here's one standard deviation up, 5.08, and then 5.16, and so on. And so then I had the students round to the closest section here. In fact, you know, data that was in here was students that scored from 5.02. I guess I rounded mine to 5.02. I probably should have put it in the other bar. So these would be 5.02 up to 5.04. Okay, would be those ones that were in that section. All right, but look at how the data fell. Very nice. Nice, very nicely located around 5. And so then here, is within 2 standard deviations. So that's good. In fact, okay, so then this question is, how did you do and how many standard deviations is your sample away? So look, my sample, I did my X bar minus the mean over the standard deviation of X bars. So that's how you're going to be doing your Z score, is going to be from your X bar minus the true mean over the standard deviation of X bars. And that's what I did. I was only a quarter of a standard deviation away from the mean. So woohoo, I'm feeling pretty good about myself on that. Now, discuss the shape of the population of all those 300 times that my students did. And that would be, we don't know. That's an important thing. I mean, that's why we are doing this. We do not know what the population of all times is shaped like. So therefore, that's why we are doing this sampling distribution, so we can trust in what that's shaped like. All right, so discuss the shape of our sampling distribution. It looks unimodal, symmetric. It appears to be centered at 5 seconds and have a standard deviation about 0.08 or maybe even less. Because look, I had 88% of the data within 1 standard deviation. What's it really supposed to be within 1 standard deviation? 68% of data. So my standard deviation may be even a little less than 0.08. I did have exactly 95% of my data within 2 standard deviations. So that was very cool. I love it when the data comes out just right. Okay, so that's the collection of a sampling distribution of the means. And now we're going to move on to, and I'll do this in a separate video, doing some application problems with this idea of sampling distributions. So now that we can then see where, even if we do not know the population data, we can take samples and we can see what those results are going to reveal to us when we know where the samples are centered and how varied the samples would be. All right, so I'm going to do these 2 little practice problems in a separate video, and then you'll have 5 to do on your assignment.